Hello student, welcome to my channel Learn Physics. Today I will be discussing the principle of dimensional homogeneity, use of principle of dimensional homogeneity to find an expression about physical quantities, and finally discuss the dimensional analysis. I will be solving the numericals of NCERT and NCERT exemplar. I have already uploaded the video of dimensional formulae of all physical quantities. So first of all, watch this video. This video will be very interesting for you. Please like, share and comment on this. And if you are new, please subscribe my channel to get the best marks in your upcoming examination. Now let's start. First of all, the principle of homogeneity of dimensions. For a correct equation, the dimension of LHS is equal to the dimension of RHS. Okay, if y equal to, this is the a plus b x square. So look at this. This is the left hand side. So dimension of this side is equal to dimension of this side. Okay. Now, for example, look at this. L, dimension of L plus dimension of L is equal to dimension of L. Okay. Dimension of L minus dimension of L equal to dimension of L. Now, dimension of M plus dimension of L. Look at this. This is the meaningless because two different physical quantity cannot be added or subtracted. Okay. Now look at this, an important numerical look of NCERT exemplar. Look at this, question number 2.14. If P, Q, R are physical quantities having different dimensions. So look at this, P and Q and R are three different physical quantities. Which of the following combinations can never be meaningful quantity? Look at this, P minus Q by R. Look at this, we know two different physical quantity cannot be added or subtracted. So look at this, this is the wrong. Okay, now PQ minus R, the product of dimension of P and Q may be R. So in these circumstances, this is correct. Okay. Now PQ by R, look at this, division or multiplication of two different quantities can be done. Okay. So look at this is correct. Now PR minus Q square, the product of dimension of P and R may be dimension of Q square. So this may be correct. Now R plus Q by P. So look at this, R and Q are two different physical quantity. So this cannot be possible. So look at this is the wrong. Okay, understood? So A and E are wrong. Okay. Now use of homogeneity of dimension. Okay, first of all, to determine the correctness of an equation, if dimension of LHS and RHS of an equation are identical, then the equation is correct, otherwise it is wrong. Okay, so number one, correctness of an equation. Okay, number two, establish an expression. Among different physical quantity. Expression among different physical quantities. Okay. And third, conversion of value of a physical quantity. Conversion of value of a physical quantity physical quantity from one system of unit to other, that is from CGS to SI, from CGS to another system of units. Okay, understood? Now, first of all, discuss one by one. Okay, now, first of all, we have to discuss the correctness of an equation. That is dimension of LHS equal to dimension of LHS is the principle of dimensional homogeneity. If the dimension of LHS equal to dimension of RHS of a given equation, then the equation is correct. Now look at this question number 2.37 of exemplar. The volume of liquid flowing per second of a pipe of length L and radius R is written by a student as V equal to pi p r to the power 4 by 8 eta L, where P is the pressure difference between the two ends of the pipe and eta is the coefficient of viscosity of liquid having dimensional formula. This is the m L minus 1 T minus 1. Check whether the equation is dimensionally correct or not. First of all, we have to calculate the dimension of LHS and the dimension of RHS. Now look at this, the dimension of LHS. Look at this. This is the dimension of LHS. Is the volume of liquid flowing per second. That is rate of volume. So dimension of this is the L cube T minus 1. Okay. This is the dimension of LHS. Now we have to calculate the dimension of RHS. Look at this. Here RHS. Now look at this pi. Pi is the number, no dimension. Then p. Look at this, the dimension of p. This is the m L minus 1 T minus 2. Okay. Now look at this. This is the r to the power 4. So look at this. This is the L to the power 4. Divide by 8. Number, no dimension. Eta. Look at this. The dimension of eta. This is the m L minus 1 T minus 1. Okay, and finally L, length. Look at this is the L. Okay, no problem. Now look at this is the L minus 1, L minus 1. Okay, m m. Okay, now look at this here, t to the power minus 2 by t to the power minus 1. So finally we get t to the power minus 1. Here L to the power 4, here L. So look at this, L cube t to the power minus 1 is the dimension of RHS. Look at this here. Look at this here. Dimension of LHS is equal to dimension of RHS. So the equation is correct. Okay. Now taken another example. Now look at this exemplar 2.13. On the basis of dimensions, decide which of the following relation for the displacement of a particle undergoing simple harmonic motion is not correct. So we have to calculate which equations are not correct. Look at this here, this 2 pi t by t is the angle. So look at this 2 pi t by t is the dimensionless, angle also dimensionless. So look at this equation is correct. Okay. Now look at this here, Vt, the dimension of angle V is the Lt minus 1 into T. So look at this, angle has dimension, this is the L. So this is the wrong because angle is dimensionless. Now see, look at this here, sine t by a. So sine theta, this is the angle. Look at this, t by a is not dimensionless. Dimension is t by L. So this is the t L minus 1. So this is the wrong. So this is the wrong equation. Now look at this, y equal to a root 2. Look at this here, sine of 2 pi tt. 2 pi small t by capital T. This is the angle and this is the dimensionless. Okay, now look at this also the angle, it also the dimensionless. So this is the correct. So our options are B and C. Okay, understood? Next. Now look at this, deducing the relation among the physical quantities. Okay, now take an example. Consider a simple pendulum having bob attached to a string. Look at this. Suppose this is a pendulum. Okay, look at this. This is the bob. Okay, that oscillate under the action of a force of gravity. Suppose the period of oscillation of a simple pendulum depends on length, mass of the bob, and accretion due to gravity. Derive the expression for its time period. Suppose time period becomes t. So t equal to some constant. Look at this, it depends on L. So look at this, this is the L to the power A. It depends on mass of the bob. So look at this is the M to the power B. It depends on accretion due to gravity. So look at this is the G to the power C. This is the probable expression of this time period. Okay. Now put the dimension. Look at this. You know the dimension of L is equal to L. The dimension of mass is capital M. Okay. The dimension of G is the LT minus 2. No problem. And dimension of T, this is the M naught, N naught, and T. Put this dimension here. So look at this. This is the M naught, N naught, T. And look at this here, K is dimensionless constant and A, B, C are the indices. Now put the dimension. Look at this here, L to the power A. Okay. Here M to the power B. Okay, no problem. And here LT minus 2 to the power C. Okay. Now look at this. This is the M naught, N naught, T. This equals to, look at this here, M to the power B. Here L to the power, this is the A plus C. And look at this here, T to the power, this is the minus 2C. Okay. Now applying the principle of dimensional homogeneity, that is dimension of LHS is equal to dimension of RHS. Now look at this here, power of M is equal to power of M. So look at this here, B equal to 0. Again, look at this power of L, this equal to, this is the power of L. So look at this here, A plus C equal to 0. And finally, look at this power of T is equal to power of T. Here power of T 1. So look at this, minus 2C equal to 1. Therefore, C equal to, this is the minus half. If C equal to minus half, so A plus, this is the minus half equal to 0. So A equal to half. Okay, no problem. Therefore, look at this. You get A, this is the B, and this is the C. Now putting this ABC in equation 1, we get T equal to, this is the K, L to the power, this is the half, M to the power 0, and G to the power minus half. So look at this, T equal to some constant K root under L by G. This is the, look at this is the expression for time period. Okay. Now using principle of dimensional homogeneity, we can calculate the dimension of an equation. Now look at this, an exemplar example. Now look at this 2.1. If momentum P, area A and time T are the taken to be fundamental quantities, then the energy has a dimensional formula. So look at this, using principle of dimensional homogeneity, we can calculate the dimensional formula of energy. Now look at this, energy E has dimension. This is the P to the power A, this is the A to the power B, and this is the T to the power C. Now we have to calculate A, B, C with the help of principle of dimensional homogeneity. Look at this here, dimension of energy. What is the dimension of energy? The dimension of energy, this is the M L square T minus 2. No problem. Now look at this here, dimension of momentum. Momentum has dimension M L, this is the T minus 1. So this to the power A. Dimension of area, this is the L square. So look at this to the power B. And dimension of time, this is the C. So look at this here. This is the M to the power A. This is the L to the power A plus this is the 2B. This is the L square into B. So this is the 2B. Now look at this T to the power. Look at this. This is the minus A and this is the C. Okay. No problem. Look at this. This is the RHS, and here look at this. This is the LHS, ml squared t minus 2. Now, applying the principle of dimensional homogeneity, you can easily calculate A, B, and C. Now, look at this. Here, here power of m is equal to power of m. So here A equal to 1. Now, look at this. Here power of L. This is the A plus 2b. This is the 2. Now A equal to 1, so 1 plus 2b, this equal to 2. So look at this, 2b equal to 1, so b equal to half. Now look at this, the power of t is equal to power of t. Here power of t minus a plus c, this equal to, this is the minus 2. Now a equal to 1, so look at this, minus 1 plus c, this is the minus 2. So c equal to, this is the minus 2 plus 1, so this is the minus 1. So you can get a equal to, so you can get a equal to 1, b equal to half, and c equal to minus 1. Now put the value of a, b, c in this equation. You can get the dimensional formula of energy. This is the p to the power a. So this is the p. This is the a to the power. Look at this, a to the power. This is the half. And look at this. Here t to the power. Look at this c. So t to the power minus 1. Look at this. This is the dimensional formula of energy in terms of momentum, area, and time. Understood? Now, next. Now, I will be discussing the third use of principle of dimensional homogeneity. That is, that is conversion of value of a physical quantity from one system of unit to other. Okay, the value of a physical quantity, this is the n into u. N is the number and U is the unit. So for a given value of a physical quantity, Nu is always constant. So look at this. This is the N1 U1. This equal to, this is the N2 U. No problem. Okay. So look at this. This is the N1 by N2. This equals to U2 by U1. Okay. If dimension of the physical quantity, this is the m to the power x, L to the power y, t to the power z, then this can be written as, this is the m2 by m1, this to the power x. This is the L2 by L1, this to the power y. And look at this, these are T2 by T1, this to the power, this is the z. Suppose N1 is the CGS value, okay, and S and N2 be the SI value, okay. So look at this, M2 becomes, this is the kg, L2 becomes, this is the meter, and T2 becomes second. Now as N1 is the CGS value, so this is the gram, this is the centimeter, and this is the second. Okay, understood? Now a numerical. A new system of units is proposed in which unit of mass is alpha kg, unit of length is beta meter, and unit of time is gamma second. How much will 5 joule measures in this new system? So 5 joule is the unit of energy in SI system. So it is the conversion between SI system and new system. Suppose this value be N1 and value in new system be N. So look at this, this is the N2 by N1. So look at this is the U1 by U. Look at this is the joule. So it is the unit of energy. So look at this, the dimension of energy. This is the M1 by M2. Look at this to the power 1. Look at this is the L1 by L2, this to the power, this is the 2. Because dimension of energy, this is the ml square t minus 2. Okay. Now look at this here, T1 by T2, this to the power, this is the minus 2. Now look at this, the value of N1, this is the 5. Now we have to calculate the value of N. As N1 is in SI system, so M1 is the kg. and M2 is the new system, this is the alpha kg. L1, this is the meter, and in new system it is the beta meter. Now it is the second, T1 is the second, but T2 is in gamma second. So look at this is the N2 by 5, this equal to, this is the kg by alpha kg. Okay, now look at this is the meter by beta meter, this is power 2. And look at this is the second divided by gamma second, this is to the power minus 2. So look at this. Now look at this, kg, kg cancel out, meter, meter cancel out, second, second cancel out. So look at this is the N2 by 5, this is the 1 by alpha, into this is the 1 by beta square, into this is the 1 by gamma to the power minus 2. So look at this, N2 equal to 5 into alpha to the power minus 1, beta to the power minus 2, and this is the gamma square. Okay, understood. Next. Now look at this. There is another exemplar numerical. If the unit of force is 100 Newton, unit of length is 10 meter, unit of time is 100 second, what is the unit of mass in this system of unit? Look at this. It is the conversion between the SI system and the new system. Now you know the dimensional formula of force. This is the F equal to M L T minus 2. No problem. Now from this relation we can calculate the mass. Now mass is equal to, look at this, this is the F divided by LT minus 2. So F L minus 1, this is the T square, is the dimensional formula of mass in terms of force, length and time. Understood? Now look at this. This is the, now look at this is the N2 by N1. So this is the U1 by U2. Now this is the dimension of the physical quantity. So you can write this is the F1 by F2 into this is the L1 by L2. This is the to the power minus 1, and this is the T1 by T2. Look at this is the 2. Now we have to calculate the value of mass in the new system. So look at this. Suppose this is the 1 kg. So N1 is the 1 kg. Now look at this F1. So this is the Newton. This is the 100 Newton. Look at this. L1 is the, this is the meter. This is the 10 meter. And T1, look at this is the second, and T2 is the 100 second. Okay. Now look at this. This is the N2 by 1. This is the Newton by 100 Newton. Okay. Now look at this. Here meter divide by 10 meter to the power, look at this, minus 1, and here second by 100 second, this to the power 2. Look at this. Now Newton cancel out, M cancel out, second cancel out. So look at this is the 1 by 100 into this is the 1 by 10 to the power minus 1, so this is the 10, and this is the, look at this is the 1 by, look at this. Okay, now this and this cancel out. So look at this is the 1 by 1 0 0 0 this. So look at this is the 10 to the power minus 5. So the value of mass is equal to 10 to the power minus 5 in the new system. Okay, understood? Now I will be discussing a very important numerical of exemplar 2.39. Look at this in the expression P equal to EL square M to the power minus 5 G to the power minus 2, where E, M, L and G denotes the energy, mass, angular momentum and gravitational constant respectively, so that P is dimensionless quantity. Now first of all we have to find the dimension of energy. What is the energy? The dimensional formula of energy, this is the ml square t minus 2. No problem. The dimensional formula of mass, this is the m. Okay, no problem. The dimensional formula of angular momentum, that is the Planck's constant ml square t minus 1. And dimensional formula for gravitational constant, look at this is the m minus 1, this is the l cube and t minus 2. Okay, no problem. Now first of all put this dimension in this expression. So look at this p equal to, look at this energy, this is the ml squared t minus 2. Okay, no problem. Now l square, look at this is the m l squared t minus 1, this is to the power 2. Okay, no problem. Now look at this m to the power minus 5. So look at this is the m to the power minus 5. And finally, look at this is the g to the power minus 2. So look at this is the m to the power minus 1, l cube t minus 2 whole square. Okay, now look at this, we can easily calculate the dimension of m. Now look at this, we easily calculate the power of m. Look at this, here power of m is the 1. Here power of m, this is the this into this, so power of m is 2. So look at this is the 1 plus 2. Here power of m, this is the minus 5. Okay, now here power of m, this is the minus 1 into this is the minus 2. Okay, so minus 1 into minus 2, so this is the plus 2. Okay, no problem. Now look at this power of l. Look at this, here power of l is the 2. Look at this, here power of l is the 2. Okay, now here power of l, this is the l square into to the power 2. So look at this is the 4. Okay, now it has no l. Here l to the power, this is the power 3 into square. So this is the minus 6. Look at this, 3 minus 2. Okay, and finally t. Look at this, here t to the power minus 2. So here power is minus 2. No problem. Here power is minus 1 whole square. So this is also minus 2. And look at this, here minus 2 to the power minus 2. So this is the plus 4. Okay. So look at this, here m naught, n naught, p naught. So look at this, p is the dimensionless. Okay, understood. Next, now dimensional analysis. Number one, added terms have same dimension. Added terms have same dimension. Okay, now look at this. If y equal to u minus v plus 2w. So look at these are added terms. So look at this, here dimension of y is equal to, this is the dimension of u, is equal to, this is the dimension of v, is equal to, this is the dimension of w. Okay. Now number 2, angle, trigonometric function, exponential function, logarithmic function, indices, all are dimensionless. Okay, that is, look at this, sin theta, dimension of sin theta is equal to 1, dimension of theta is equal to 1, dimension of exponential function this is equal to 1, dimension of index, this is the x, also equal to 1, the dimension of logarithm function log x, this also equal to 1. Okay, understood. Now Now a numerical. But this the van der Waals equation for 1 mole of a gas P plus A by V square into V minus B equal to RT. We have to calculate the dimension of A and dimension of B. Okay. Now look at this. Here P plus A by B square are the added term. Look at this. P and A by B square are the added term. So from dimensional analysis, the dimension of P is equal to dimension of A by B square. No problem. Now look at this. So dimension of A equal to dimension of PV square. Look at this dimension of P. This is the M L minus 1 T minus 2. B, this is the L to the power 6. Okay, no problem. So look at this. This is the M L to the power 5 T minus 2 is the is the dimension of A. Now look at this here. V and B are the added term. So look at this dimension of V is equal to dimension of B. So look at this. B has dimension same that of volume. Now volume has dimension L cube. So look at this. B equal to L cube. Okay. 2 point. Now look at this question number 2.34. This is another numerical. Look at this. The displacement of a progressive wave is represented by y equal to a sine omega t minus kx, where x is the distance, t is the time. Write the dimensional formula of omega and k. Now look at this. Sine of this. This represents the angle. So omega t minus kx represents angle. You know angle has no dimension, so its dimension 1. As omega t and kx are added term, so dimension of omega t equal to dimension of kx, this equal to 1. So look at this omega t, this equal to, this is the k, dimension of x is L equal to 1. So look at this omega has dimensional formula t minus 1 and k has dimensional formula Look at this is the L minus 1. Okay, understood? Many thanks for watching this video. This video will be extremely helpful for class 11 NEET main advanced because all the numerical solved for you are all from NCERT and NCERT exemplar. Please like, share, comment on this. And if you are new, don't forget to subscribe my channel to get the best score in physics. Okay.